So now we will see the next concept, test of divisibility. So under this concept they ask many questions, and now this test of divisibility will be useful for you to check whether the number is divisible or not without doing the actual division. So we will see test of divisibility of the numbers from 2 to 11. So first we will see test of divisibility of 2. So test of divisibility by 2. So if the last digit is an even number or if it is 0, then the given number is divisible by 2. So we will see the working. See, suppose the number is, so as this is an even number, that is the unit digit, if it ends with 0, 2, 4, 6 or 8, it is an even number and this number is divisible by 2. If it ends with odd numbers, that is 1, 3, 5, 7 or 9, so then that number will not be divisible by 2. So we will see the next test for divisibility of 3. So test of divisibility by 3. So when the sum of the digits of the given number is divisible by 3, then the number is divisible by 3. So we will see the working. Say if you have a number, so 5193. So you add all the digits and check if it is divisible by 3. So when you add all the numbers, so 5 plus 1 it is 6, 6 plus 9 it is 15, 15 plus 3 it is 18. So we get 18, which is a multiple of 3. So 18 is divisible by 3. So the given number is divisible by 3. Suppose, so instead of 3, you have 2. So now when you add the number, you will get 17. 17 is not divisible by 3. Therefore this given number 5192 is not divisible by 3. So now we will see test of divisibility of 4. So divisibility by 4. So if the last two digits of the given number is divisible by 4, or if the last two digits are 00, so then the number is divisible by 4. So we will see the working. So the given number is 6248 and this last two digits 48 is divisible by 4. So then the number itself is divisible by 4. So instead of this 8, suppose if you have 2. So 42, though it is an even number, it is not divisible by 4. So the given number 6242 is not divisible by 4. So we will see next for 5, divisibility by 5. So test of divisibility by 5. So if the last digit of the given number is 0 or 5, so obviously the number will be divisible by 5. So we will see an example. So 9915, this number ends with 5, so it is divisible by 5. And here 9970, so this also ends with 0, so both the numbers are divisible by 5. So if you have other numbers than 0 or 5, so the number will not be divisible by 5. So next we will see for divisibility by 6. So test of divisibility by 6. So to check whether the number is divisible by 6, we have to see if the number is divisible by both 2 and 3. So we will see an example. Suppose you have a number 6624. So this is an even number, so it is divisible by 2. And you have to check whether the number is divisible by 3 or not. So for that, you add all the digits. So when you add, it is 6 plus 6, 12, 12 plus 2, 14, 14 plus 4, 18. So when you add all the digits, it is 18. So 18 is divisible by 3. So the given number is divisible by 3. So it is an even number, it is divisible by 2. And when you add all the digits, you get 18, it is divisible by 3. So the number is both divisible by 2 and 3. Therefore, the given number is divisible by 6. So we'll see test of divisibility for 7. So to test whether the number is divisible by 7, you take the unit place of the given number, multiply it with 2, and this product you subtract from the remaining digits of the given number. So if it is divisible by 7, the resultant, if it is divisible by 7, the whole number is divisible by 7. So we'll see an example. Say you have a number 7504. So to check whether this number is divisible by 7 or not, so you take the unit place of the given number, so which is 4, multiply it with 2, so you get the product as 8. So this 8 is subtracted from the remaining digits of the given number. So the remaining digits, you have 750. So when you subtract, so you have 742. So further you can proceed the same pattern. So the unit place is 2. Take the unit place, multiply it with 2, it is 4. And you have to subtract this 4 from the remaining. So when you subtract, you get 70, which is a multiple of 7. So 70 is divisible by 7. So obviously this 7504 is also divisible by 7. So now we'll see test of divisibility for 8. So to find, to check whether the number is divisible by 8 or not, the last 3 digits of the given number should be divisible by 8. So if it is divisible by 8, or if the last 3 digits are zeros, then the given number is divisible by 8. So we'll see an example. So here the number is 11864. So you take the last 3 digits, 864. So you check whether this 864 is divisible by 8. So 864 is divisible by 8. So 8 ones is 8. And for 6 we write 0, and 64 is divisible by 8. So this 864 is divisible by 8. Therefore, the given number is divisible by 8. So now we'll see test of divisibility for 9. So if the sum of digits of the given number is divisible by 9, so then the number itself is divisible by 9. So we'll see an example. Say the given number is 7281. So you add all the digits. So adding all the digits, we have 7 plus 2, 9. 9 plus 8, 17. 17 plus 1, 18. So sum of digits is 18, which is divisible by 9. So therefore the number itself is divisible by 9. Suppose instead of this 1, so if you have 2 or 0. So here if it is 2, when you add all the digits, so sum will come around 19. So 19 is not divisible by 9. So the given number is also not divisible by 9. So we'll see test of divisibility for 10. So to check whether the number is divisible by 10 or not, so it is clear that the unit place should be 0. So if it is 0, the given number will be divisible by 10. Say for example, so if the last number is 0, this number is divisible by 10. So we'll see test of divisibility for 11. So now we'll see test of divisibility for 11. So for a given number, pick out all the numbers occurring in the even places and add all those numbers. And pick out the numbers occurring in the odd places and find the sum. So then find the difference between sum of all even places and sum of all odd places. So if the difference is 0, or if it is a multiple of 11, so then the given number is divisible by 11. So we'll see a few examples. Say suppose the given number is 757163. So we have to check if this number is divisible by 11. So we pick out all the numbers occurring in the odd places. So we have 7, 7 and 6. So adding all this, 7 plus 7 is 14 plus 6 is 20. So now pick out all the numbers occurring in the even places and find the sum. So we have 5 plus 1 plus 3. So adding 5 and 1 it is 6, 6 plus 3 it is 9. So sum of all even places is 9 and sum of all odd places is 20. Now find the difference between these numbers. When you subtract sum of odd and even places, so we get 11. So as it is a multiple of 11, so the given number is divisible by 11. So we'll check with another example. So 8, 4, 1, 4, 3 and 4. So now we'll check if this number is divisible by 11. So now again picking out the numbers in the odd places. So we have 8 plus 1 plus 3. So 8 plus 1 is 9, 9 plus 3 it is 12. And now pick out the numbers in the even places. So sum of odd places is 12 and sum of all numbers in the even places is also 12. When we find the difference of odd and even places, sum it is 0. So here we have got the difference as 0, therefore the given number is divisible by 11. So this number is divisible by 11. Suppose if we add 3 zeros, so to check whether the number is divisible by 8, so we have seen that if the last 3 numbers is divisible by 8, or if the last 3 numbers are 0, it is divisible by 8. So here we have the last 3 numbers as 0. So whatever number you have or any number of digits you have, if the last 3 digits alone is divisible by 8, so the given number is also divisible by 8. So now we have seen the concepts of test of divisibility. So using this, you can check whether the number is divisible by the given divisors or not. So to sum up, the presentation objectives of this lesson. After at the end of this session, so you will be able to solve the problems relating to B. Bodmer's concept, decimal multiplication and division, test of divisibility, remainder and divisor, summation of series, exponents of numbers, values of unit digits, reversal of 2-digit numbers. So we have seen all the concepts. So go through the concepts thoroughly and practice well, and you will be able to crack out all the 10 questions in this simplification part. So now we'll see the workings of the questions.